Okay, good morning, everyone, and thank you for joining our webinar that's going to help you stop the leak in your Wetcast production efficiency. My name is Derek Von Cannon, and I'm the Vice President of Sales for Afinitas. For those of you who don't know, Afinitas is a major provider of equipment and services to the precast concrete industry and the parent company of Hawkeye Pedershab, BFS, New Hampton Metal Fab, Spillman, and CAM Products. While today's presentation is going to focus on our Prima automated Wetcast system, we also want you to be aware that our Prima brand is expanding to include advanced monolithic manhole-based design software and production equipment. That technology is not new to Hawkeye Pedershab and BFS, but what is new is how we are bringing the best engineering technology both companies have to offer into manhole production capabilities that will benefit your business. Watch for details as we'll be discussing our Prima-based system in greater detail in a future webinar. So before we get started on today's presentation, here are a few housekeeping items to note. First off, you will be muted during the presentation, but can submit questions through the chat box on your screen. We will take as many questions as time allows after the presentation. Also, we're recording the presentation, so you will receive a follow-up email with a link to the replay and a PDF of the slides. All right, so let's get started. I'd like to introduce our company's Prima expert, Jason Banwart, who will lead the discussion today. Jason is the Director of Technical Sales at Afinitas. He has been with our company for 10 years and has worked in a variety of design and project engineering roles. For the past 3 years, he has led the inside sales and application engineering team for Hawkeye Pedershab in Mediapolis, Iowa. Jason has a bachelor's degree in mechanical engineering from Iowa State University and is licensed in the state of Iowa as a professional engineer. Well, Jason, we have an interesting presentation lined up, and I know there are a lot of things keeping our customers awake at night. And today we're going to address several of them.
I agree, Derek. We've got a lot to talk about. So I'm going to switch off my webcam and we'll dive into it. And first, we just want to thank all of you for joining the call today. We really appreciate you taking time out of your day to be here, and we feel we have some information to share that could really help your business. As Derek alluded to, we know your day is filled with a lot of challenges, starting with, am I going to have enough labor to cover my shifts? The disparity between the number of people entering the field of manufacturing and the needs of the industry is huge. According to Deloitte, estimates put the manufacturing labor shortage at 2.4 million by 2028. And even though you're short-handed, you are still expected to deliver the same quality and the same output with the same measure of profitability. It can be a tall order. That's why today we want to help you find answers to some of these questions that create the challenges you face. So as you think about your operation, do you find it difficult to hire and retain motivated employees? How about tracking your labor input down to the piece that's produced? Do you find it difficult to measure the efficiency of your production? How about identifying waste in your process? And so, as you think about your Wetcast production, does it include any wasted motions or inefficient processes? Are there any unsafe processes like overhead crane lifts, moving heavy products above your employees? Do you deal with any space constraints? Derek, as we consider all these challenges that producers are facing, that's why we're here today, to discuss a solution to these challenges.
Great, Jason. We feel the solution to these questions can be answered with Prima automation. In visiting with a lot of you and other precasters, the below list of 4 items are the key takeaways of what Prima automation will address. During the rest of the presentation, we'll discuss ways our Prima system will, 1, help you ease labor issues. I believe we could all agree that it continues to get harder to find labor, and good labor at that. Number 2, we will discuss how Prima will help you increase profitability and throughput. Number 3, we will discuss how Prima will help you improve plant conditions. We all want conditions that are safe for our employees, and this ties back into helping with easing labor issues as well. The better our plant conditions, the easier it might be to keep our good labor. Fourth, we will discuss how Prima will help position our company as a leader. But first, Jason, why don't you give us a quick overview of what Prima is and how it works?
Sounds good, Derek. You've all heard of Henry Ford, right? Well, we're putting his ideas to work with Prima. So Prima is really a cutting edge production management system that's bringing the assembly line principle to wetcast concrete production. So forms move through a production loop down a process line. They're cured in a form inventory area, and the cured products are removed from the form and they exit the building on an outfeed line. So to dive in a little deeper to the process line, forms are delivered automatically from an inventory area up to the process line. The product is removed from the mold and placed on the outfeed line, and then the mold proceeds through a series of workstations to a fill station where the concrete is added back to the mold, and then the mold is transferred back to the inventory curing area. So each employee works at a stationary workstation while the molds come to them, as opposed to the employees going to all the individual molds and bringing concrete to the molds. So that's kind of a description of the production loop.
So, Jason, one of the main questions that we continuously hear is what type of products can the system handle?
Great question, Derek. The beauty of our system is that it's not limited to a particular product. It's extremely flexible because every form rides on a common size of carrier pallet, or what we call a tray. So it's not specifically designed for one type of product. Really, any form that can fit on a tray can fit in the system. And our system is really unique because we're able to use your existing form equipment. Now, we do want to point out that some forms are not necessarily designed to be used. They're not efficient in an assembly line process. So if you have a form that comes apart in a lot of parts and pieces, that might not lend itself to being an efficient form for the Prima system. But that's something we can look at with you. And we can mix old forms and new forms into one system. With our new forms, we design in a lot of great time savings features like having rollback jackets and ganged latches on the jackets so they can quickly be opened, quick strip collapsing cores, and then we can design that carrier pallet or tray right into the sub base of the form so you don't have to buy an additional tray. So really the designs with the new forms, they're geared toward making it very quick and efficient to open your forms and get the products out and allow the form to move down the process line as one piece. So we're going to kind of walk through through each station of the system, and we're going to start with the DMold station. So it's the first station along the process line. So as the form with the product moves up to the process line, the mold is opened up and the product is removed from the mold, and the product is placed on the outfeed line. Now, typically with a plant running a variety of products, we use just an overhead crane with a variety of attachments to lift the products out of the molds. If we're looking at a plant that runs a lot of the same products, maybe it's a plant running only manhole bases and risers, then we can look at more of an automatic demold option where we just can automatically grab the products and place them on the outfeed line. But we found for a variety of products, the overhead crane works well. So the products are then placed on the outfeed line, which is really an elevated ergonomic platform that exits the building. And this is where any of the post-processing can happen to the product. That could be things like removal of blockouts or EPS, product marking, quality control checks, and really anything that needs to happen to the product before it exits the building to head to the yard. Next comes a series of intermediate workstations. The number of stations and the functions that happen at each station is really kind of dependent on the products that are running through the system as well as the form design. But each station is equipped with everything necessary to perform the task at that station. And that can be things like tools, consumable products, reinforcement. And this is really a great way to organize all the steps, inserts, blockouts, and those type of things. A lot of times we'll see these scattered about the production area, and it's difficult to organize them and efficiently flow them to each form as they're needed. But with Prima, they're stationed in an organized manner right where they will be used. So an example of what the process line might look like is once the product is removed from the mold, station number 2 could be cleaning and oiling. Then it moves into the next station where the reinforcement's loaded. The next station, the form is reassembled and maybe a lift insert is placed in, and then the form is buttoned back up and ready to head to the fill station. Some of the great features that we have along the process line include the customizable heads-up display, which is kind of a real-time scoreboard for the operators. It shows them things like the upcoming queue so they can prepare for the forms that are coming next. It shows a countdown timer so that they have a sense of where they're at in the cycle time. And then we have a nice ergonomic production mat along the line for a ergonomic work surface. And then each station has a control post with a button on it. And so when the operator finishes their task at their station, they simply walk back and hit the button. This indicates to the system operator that the task is complete and the system's ready to index. And it also logs the data point of when that cycle was completed and puts that into a file. And we'll talk about that later on in the presentation. We do offer an optional kick-out line or offline exchanger. And this was really used just to move a form out of the production line and not hold up the rest of the line. And this could be for situations where maybe the form needs repaired. Maybe there's an extra long setup or assembly procedure that needs to happen. We just simply shuttle the form offline. It can be repaired or whatever needs to happen to it is done. And then it can be shuttled back in line and continue through the system without slowing down the rest of the assembly line. So the form is buttoned up and is ready for the fill station. And this is where really the overall operation of the system happens. The main system operator is on an elevated platform, and he has industrial video cameras to monitor the entire system. And he is the one that's running the feeder as well. And we can do a variety of filling methods and really work with any type of mix, whether it's SCC or traditional Wetcast. Our most common option for a feeder would be what's shown here on the slide. It's a troughed conveyor belt, high-speed conveyor that can pitch up and down and swing side to side and fill a wide variety of shapes and sizes. We can also look at applications where we can use a concrete pump and placement boom or maybe an overhead gravity-fed bucket. Really just depends on the mix and then the products that are being made. As an option, we can put a vibration table or oscillation table underneath the mold at the fill station. And so with a vibe table, that would eliminate the need for vibrators to be mounted on each form. And so the forms are simpler and less costly. So as the forms move out of the fill station, they are ready to be placed into the form inventory area. This is controlled by an automatic overhead manipulator. And the manipulator grabs the tray and the form that have just been filled and moves them to a specific location in a grid in that form inventory area. Next, it drops off that product, and then it goes and picks up a cured product from the previous production run and brings it up to the front of the assembly line where it can start to be processed. So this area is completely safetied off with no personnel in the area, and it's 100% controlled by the automatic manipulator. And as you can see, we get the products nested very tightly in the inventory area. So the beauty of our system, or one of the great things, is the advanced production software. Each tray that each form is sitting on contains an RFID tag that is read at various points throughout the process. Now that RFID tag can have information about the form, and that could be things like the inventory position and the ID of the tray. It could be estimated times that it should take at each station, estimated manpower that's required at each station. Things like concrete mix design and vibrator speed settings, and if there's like a minimum cure time that the product needs to spend in the curing area before it can be reintroduced to the line, that can be built into the system as well. So it really allows the operator to build a smart production queue based on the data that's built into each form. And so as the user is building out the queue, they can see the demand for concrete and manpower throughout the day, and really allows them to balance and optimize the throughput and the manpower demand. So that's kind of an overview of what the Prima system looks like and how it works.
Great. Thanks, Jason. Okay, now you can see what the Prima system consists of. Let's break down what this functionality means to you in terms of benefits and ROI. Why don't we start with labor?
Right. As we talked about earlier, the Henry Ford idea of assembly line efficiency will help you be more efficient. For example, today, you might have personnel aimlessly walking around looking for tools and consumables, waiting for concrete to come to the form, forklifts weaving in and out of forms back and forth from the mixer. Well, with Prima, there's no wasted motion or time spent waiting. Every task is broken into a manageable bite at a specialized workstation, and that results in maximum efficiency. In fact, we've seen up to 50% labor reduction over traditional Wetcast operations, which can drive a rapid ROI and really give you a decisive advantage over your competition.
Labor is huge, Jason, but it is getting increasingly difficult for businesses to be profitable. How do you see Prima making an impact here?
Well, a typical Wetcast plant setup makes it nearly impossible to drive productivity. There's just too many variables and there's no linear process flow that can be measured and analyzed and optimized. One of the top principles of lean manufacturing is creating a flow, and that's exactly what we're doing with Prima. It's about creating a system where you can drive continuous improvement. And Prima really brings accountability to the individual operators and exposes potential problems or inefficiencies in the process. We've got that large visual scoreboard, and it has a countdown of each cycle time to promote that accountability. So employees know immediately if they're falling behind, and they can adjust accordingly. This promotes some healthy competition, or what we like to call operational tension. Nobody wants to be the last person to push their button to complete their task all throughout the day. And so it's going to drive the employees to be more productive, and then allow us to measure that productivity day to day and by product and even by employee. So an example of how Prima exposes the bottlenecks like this is we have a current Prima system that runs retaining wall blocks and manhole base products, along with a variety of other products. And what they found with Prima that just made it very clear, when they were running retaining wall products, it took a lot of labor to open the mold and get that product out. But once they got the product on the outfeed line, it really didn't take, there really wasn't much to do to it, and so the labor was very minimal. Now, conversely, when they were running manhole bases, it was relatively easy to open the mold and get the product out. But once that product was on the outfeed line, they had to pull the hole formers and remove the EPS invert channel, mark the product, do the quality control checks. And so it took a lot more labor on the outfeed line. And so Prima exposed the need to shift the manpower and allowed them to utilize their labor for maximum efficiency and productivity. Now, we haven't really talked about the cycle time yet or staffing requirements, but in general, we try to arrange the tasks at each station to hit a 4.5 to 5 minute cycle. And the equipment is certainly capable of processing at that pace. It's really a matter of breaking up the tasks so that they can each be completed in that amount of time. Now, as far as the direct labor in the system, this depends on a number of factors like product mix, product size, the design of the forms, but an average system might look something like this. There would be the main system operator at the fill station. There'd be a person at the DMold station pulling the products out of the mold. And then as the mold moves along the line, generally there's 2 or 3 stations. So you may have an individual at each of those stations. Whether or not you need the, person number 5 would be would depend on your form design and your process. And then on the outfeed line, you'd have 1 or 2 personnel as well to process the products. And again, that depends on the products. And so we typically say in the neighborhood of 5 to 7 people are required as direct laborers in the Prima system. And now, as we think about the cycle time of 4.5 to 5 minutes, an output of 90 to 100 pieces a day is attainable in just a single shift. So the system is all about getting more production with less labor. I think it goes without saying that the cleaner and more comfortable your factory is, the better the work environment for your team. And this is going to help you attract and retain better employees, and happier employees are typically more productive. But in addition to that, they'll be safer as well. Prima is fully safety compliant. It virtually eliminates the forklift traffic in the plant, and there's no unsafe overhead transport of products or concrete above the employees, and each station is built around ergonomics. So this really takes your work environment to the next level.
Jason, this might not be something that everyone thinks about all the time, but a change like this can open up a host of opportunities.
Exactly. A cutting edge system like this really positions your company as a leader in the marketplace. With more output and shorter lead times, you're going to win more business. And one of the things that really excites me about the Prima is the data collection and logging that we do. As we discussed, the cycle time for every task is logged whenever the button is pressed at each station. Well, that data is collected into a CSV file. And at the end of the day, that can be used to generate reports and dashboards to measure productivity. And that can be done in Excel. I mean, if you use a business intelligence software like Power BI or Domo, for example, that CSV data could be pushed into those systems. And so it really gives you a great look at what's happening in your operation. You know, in many Wetcast operations, it's kind of a macro planning approach where a certain number of people are expected to make a certain number of products in a certain time frame. And if that doesn't happen, then we're kind of left scratching our heads and wondering what caused it. Well, with Prima, you can do micro planning. It's data for each product and task being broken out that can be used to drive out waste and increase production. So now you can make decisions not just on intuition, but you get data to back it up and really drive those decisions. And as we talked about, this brings accountability to not only your people, but your processes as well. Now, having a plant that's a showcase of technology is great for plant tours, marketing opportunities, and really attracting the best employees.
Great, thank you again, Jason. So we know what Prima is, what it can do, why it can benefit your business. Now let's hear from one of our customers, Joel Sheets, Vice President and General Manager of Tyndall Corporation. For those of you who aren't familiar with Tyndall, they got their start in 1932 as a small concrete manufacturing business in Spartanburg, South Carolina, specializing in manufacturing concrete utility pipes. Since then, the Tyndall family has grown to include 5 manufacturing facilities in South Carolina, Virginia, Georgia, Mississippi, and Texas. Tyndall is in the process of installing Prima, so we thought it would be valuable for you to hear Joel's take on what you need to consider when thinking about automating your Wetcast production, and also why he chose the Prima technology for his operation.
My name is Joel Sheets. I'm the Vice President and General Manager for Tyndall Corporation's Utility Division. I've been with the company for 19 years, and in this role as the General Manager, I'm responsible for all activities of the Utility Division, starting with sales and going all the way through production and fulfillment to our customers. I would say to precasters that are considering automation, the first step is to decide to what degree you want to automate your process. There are small steps you could take, like buying tie guns to improve your rebar tying speed. There's the next level of maybe a CNC router that adds automation to your system, all the way up to a full-blown system like Prima, where you're automating the whole process. I would think precasters would want to consider first their labor pool. I mean, that's the biggest reason most of us are automating, is because it's hard to find labor. So you're going to balance the skill, availability, and cost of that labor versus the cost of capital to put in levels of automation. In going through this process building our new plant, our major focus is expanding capacity and capability without increasing labor by the same amount. After reviewing several systems, we decided on Prima because of the relationships we've had with several of the Afinitas companies. At Tyndall, there are several advantages to using the Prima system. Currently, we use a kiln curing system that limits the size of the products that we can put into it. As we move to the Prima system, we can put in much larger products than we currently use. By doing this, we will increase both our capacity and our capabilities without having to substantially increase our labor. Tyndall plans to utilize the Prima system to increase the size of what we can make in an automated capacity. we'll be producing 4, 5, and 6-foot diameter manholes, as well as some boxes in our system that truly utilizes a manufacturing process like an assembly line. Each of the forms will come to our team members and they will stay in one spot as the form moves down the line. So far, the process of getting Prima to Tyndall has gone very well. For anyone who's ever dealt with new construction, the challenges are endless, and that has been the case here. However, the teams both at Afinitas and Tyndall have worked together to resolve everything that has come up, and we should be fully operational in May or June of this year. For Tyndall, the process of working with Afinitas has been a very positive one. We came to the project with unique and specific challenges that had to be met. So far, they found a solution to all of the challenges that have come up. This has been a great opportunity for us to learn, and I think we've challenged them on some new solutions that they hadn't done before.
Well, a big thanks to Joel for sharing his thoughts on the process, and we certainly share his enthusiasm for the benefits of automation in building more profitable business. Some of the items you need to consider are listed here.
Yeah, as Joel mentioned, there's a lot of considerations that go into the planning of a system like this. And so where we like to start the discussion is the number of products you're looking at, the size of those products, the size of the forms, because that really sets the overall space requirements for the system. The forms have to fit within a defined maximum tray width that has to be the same for all the products. And so we design the system around that maximum width. And then the size of the forms and products also set the capacity of the automatic manipulator. Now, the type of products being produced can also affect what's required at the workstations, maybe the filling requirements as well. So we have a team of engineers that just love to dive into these discussions about Prima and how it fits with your product mix. And we have two standard sizes of the system that we like to start the discussion with. We've got the 20-ton system that features an 10-foot wide or 120-inch wide tray. Now that width has to be the same for every product, but we can vary the length. So we can go with 8-foot, 10-foot, 15-foot tray lengths, depending on the size of the molds, as long as they all fit within that 10-foot width. And the max overall form height is 124 inches. We've got the slightly smaller 15-ton system that allows the tray width to be limited to 90 inches. And this works well for situations where the size of the building might be a constraint, or maybe the max product size just doesn't need to be that big. And we can be a little more efficient with the space with the smaller trays. Again, we can go with the varying lengths, 8, 10, 11, and 15 feet long, and the same overall height. Now, for a sense of scale between the two systems, the 20-ton system would be able to accommodate something in the range of like a 72-inch by 8-foot extended base monobase product, and the 15-ton system could accommodate like a 60-inch by 8-foot standard monobase product, just for a kind of a sense of scale on what would fit in the system. We often get the question as well about the building size requirements, and typically we like to see 2 adjacent bays that are maybe 70 to 75 feet wide and probably a minimum of 200 feet long. That would be kind of sized for an average of like a 1-shift production. Now we can go longer on the building as well, maybe up to 275 to 300 feet long, to get more products in the carrying area for a larger capacity system, or to leave room for future expansion. So these are the type of specifications our applications team can dive into with you to define the size of the system and the building and all those details. So to conclude, we've walked through how Prima can help take your business to the next level and solve some of the common problems you face by helping you ease your labor issues, increase your profitability and throughput, improve the conditions in the plant, and really position your company as a leader in the marketplace. And that kind of wraps up the presentation of the system itself. So we really appreciate you joining us, and I hope you found some value in what we discussed today.
Thanks for a great presentation, Jason. We trust you all have a better idea how automation will help you grow your business. At this time, we will address some of the questions that have come in during the presentation. And just as a reminder, You will receive a follow-up email with a replay of this presentation and a copy of the slide deck as well. Let's start off with question number 1, Jason. Ask, what skills do the operators need?
Great question, and it's one we get quite often. Really, the Prima main operator that's running at the fill station would need general computer skills for running the overall system, but all the other positions along the line really don't require any special knowledge or requirements. It's really the same tasks that the employees are doing now. It's just in a more organized manner. In fact, one of our customers puts their newest employees on the Prima line because it's an easy place for a beginner to learn, because you're doing the same task repeated all day long. And so it's a way for beginners to come in and quickly learn every task that needs to happen on the process line.
Great information there, Jason. Next question. What is the largest box structure that can be made with Prima?
Typically, it kind of depends on the form design a little bit, but on the 20-ton system, we can typically do up to like a 5x5 by 5 or 6 foot tall box product that can still utilize like the rollback jackets in the form that's really conducive to an efficient process.
Great. Can an existing building be used?
The answer is it depends. So existing buildings can work with the correct bay sizes, and that's something we can study with you and look at whether an existing building or a new building would be the best option. A lot of times if the bay sizes are correct, and we can make it work. One consideration as well for an existing building is there is some small foundation work required, some roughly 2 feet deep trenches that run the length of the process line, and also the transfer carts between the 2 bays. So there would be a little bit of concrete work required as well. But again, that's all things we can look at for each specific situation.
Okay, great, Jason. Kind of dovetailing off of that one, it looks like here is, what is the turnaround time to have a plant built?
Typically, there's a period of back and forth during the design time. Now, once we get the design nailed down, the quote nailed down, and we would get an order, it really depends on the loading in our factory. So I can't give it a specific lead time, but I would say, maybe an average of roughly 6 months for delivery, and then a period of a couple months to install and commission the plant. But of course, that depends on how busy our factory is when the order is placed.
Great. We've got quite a few questions here, Jason. Here's another one. Is there a way to do an entry-level Prima?
So this is another question we often get. The system is intended to be installed as a complete system. Otherwise, a lot of the benefits of the system are not realized. Now, that being said, there are steps you can take. I mean, one thing we've seen producers doing as they prepare for a future Prima is they're buying new forming equipment with the anticipation of putting in a Prima. And so they're making sure that some of the Prima ready features are being designed into those forms. So it's very easy to drop the forms into a Prima system. And so this is a topic we can discuss with you individually, and we can offer ideas based on your specific situation and goals.
Next question. Do you make an individual batch of concrete for each mold?
Not necessarily. So the feeder typically would have a 3 or 4 yard holding hopper to where we could receive a batch of concrete and then fill a number of molds. But as the products get larger, they may be taking a full batch just to fill, depending on the size of the batch plant and the size of the products. And so it really doesn't, Prima doesn't demand one way or the other, where we use all the concrete for one form or use concrete for multiple products.
Hey, Jason, how is curing accomplished in the storage area?
Again, depends on environment, depends on the curing requirements. Oftentimes it's just the products are placed in ambient temperature and cured. We can also look at curing solutions. So once the products are placed, we could look at a like a telescoping kiln design that would come out and cover the products, and actually we could implement steam curing if needed. We've looked into also doing heated floors to help accelerate the curing on that side of the building. So we've got a variety of options there to help with curing if needed.
Great. How do you fill a riser form with an open top header?
Great question. So we have on that feeder that we saw on the slides, we have a quick attachment that just hooks onto the end of the feeder when the risers are running through. And it basically has a funnel that's profiled. It's kind of a long, narrow opening that's kind of profiled in the radius of the riser. And that fits right above the opening between the joint ring and the wall of the form. And so we can drop the concrete right down in that opening with the attachment on the end of our feeder. And once the risers are done running, we just simply unhook the attachment and set it off to the side.
Okay. Can you do a system larger than 20 ton?
So we've studied this, and what we found is once we get over that 20 ton capacity, the capacity and demand of the automatic manipulator starts to go up exponentially. Now that's not to say we couldn't do something a little bit larger than 20 ton. I mean, it would depend on the span of the manipulator as well. But as far as like the cycle times that we need to hit and the acceleration of the manipulator, the costs just go up exponentially. So there seems to be kind of a practical limit of where it makes sense to bring all the forms to the concrete versus bringing the concrete to the forms. And we've got other solutions for larger products where we're delivering the concrete to the forms in a more efficient manner. This kind of the step up from just manually filling those forms.
Okay. What should clean time take after 8-hour shift?
It again depends on some of the factors like how tidy are the molds? Are they sealed up? Is there a lot of leakage coming out? There really shouldn't be a lot of residue along the production line, because as the molds are opened up and they have those trays underneath them, that catches a lot of the flakes of concrete that might come off. There's really no mess in the inventory area, and then along the outfeed line, it would be your basic cleaning that would need to be done at the end of the shift. But it really is not a great deal of cleanup, and all the production line is completely covered with that production mat as well. So it's a matter of just sweeping up the flakes or dust that come off the forms throughout the day.
Okay, Jason, how do you compare to the competition?
Well, we really feel that we have the most flexible system in the market. We're not just designed around making manhole bases, and we're really geared around making all types of precast products, and also the ability to mix and match with existing and new form equipment. And with the Wetcast forming expertise that we have between our Spillman company and New Hampton companies under the Afinitas umbrella, that really gives our system an advantage. And then not to mention the world-class service and support that we're able to provide out of our US-based facilities.
Great, thanks. All right, Jason, as of right now, it looks like we're down to 3 more questions. If anybody has any further, just put them in the chat. But the next one is, can products be made in a 2-shift operation?
Yes, it's very possible to run a multi-shift operation with Prima. Of course, like we've talked on other things, the mix design and curing requirements differ in every situation. But really, as soon as the product has been cured long enough per your requirements, it can be pulled up to the production line again. And that's really a big advantage over kind of a traditional wet cast operation, where pouring a second shift could be a little bit cumbersome or take a lot of planning. It's very simple to just queue up the product again, and the operators on the line and the system itself really don't care how many times the form is running through the system. It really just depends how much time is needed in the curing environment, and then it can be queued up again. And that, with a 2-shift operation, that really makes the labor savings and the ROI look very compelling.
Hey, Jason, next question. Can the system have different sizes of base?
I assume the question is referring to the size of the tray or the carrier pallet. And the answer is the width has to be the same, because as you can see actually in this picture right here, I'll point it out with a highlighter, but the manipulator grabs the trays on the sides, and that's a fixed width from this point to this point. So every width has to be the same. Now the length of the tray can vary, and so that can stretch out well beyond the arms of the manipulator. And so that could be anywhere from, maybe 8 feet at a minimum to 15 or 16 feet as a maximum. So the answer is the width has to be the same, the length can vary.
Hey, thanks for the visual there, Jason. Looks like we had another one come in here. Are cages placed in forms manually?
Yes, typically we would have a little jib crane along the line that could assist with placing the cages if they're larger. If they're smaller, they can just be placed by hand as the mold is opened up. And so that's another one of those details we work through as we're defining the workstations and the products being run. We look at what handling assistance is needed for loading various things into the molds. And typically we'll have 1 or 2 jib cranes along the process line.
Jason, another question here is there a minimum number of forms the system needs to make it feasible?
I would say, yeah, if you're going to try to justify it with an ROI, you would want, probably close to a full day's production to make it work. But there's nothing saying that the system has to have, X number of forms to make it work. I mean, it can work with any number of forms. But if you're, setting it up for 80 products and you only fill it with 40 forms, you're kind of just leaving that extra capacity on the table, and it's really not contributing to your payback. So maybe kind of hard to answer that in a general sense, but certainly as we would dig in a specific situation, we could look at what makes sense for the producer.
Perfect. Looks like we might be down to 2 more. We've had a couple more come in, but can a curing solution be implemented?
I believe we already talked about that one, and the answer was yes, we can incorporate a variety of curing solutions in the form inventory area.
Hey, Jason, sorry. It looks like there's one chatting in as we speak, so give me just 1 second.
A lot of great questions. Appreciate everybody that submitted the questions so far.
All right, well, I think that was it. I don't see any others. Sorry, it looked like there was one more coming in. Jason, a big thank you for the presentation and answering our questions today. A couple notes here. My contact information is on the slide and will be in the content you will receive after this webinar, along with the questions and everything else. If you would like to discuss Prima further, please reach out to myself or any of our sales executives. And again, wrapping up here, thanks again for attending our Prima webinar. Feel free to reach out anytime, and we'll set up an on-site visit to see how Prima can work in your facility. And stay tuned for more on our expansion of the Prima line with our next generation monolithic manhole-based system in an upcoming Afinitas webinar. Thanks again to everybody for participating, and have a good day.